Okay, in this section we're going to go over the derivative. So homework are due on Tuesday. And from your previous Math 121 class, I put here, remember, slope is technically m is equal to y2 minus y1 over x2 minus x1. And if we call our first point x1, y1, and our second point is x2, y2. Another way we can call the first point is x comma f of x. And the second point, if instead of going from x1 to x sub 2, we just say we're going to go from x, but h spaces, that's going to be our new second point. And so f is going to be f of x plus h. And so here, reviewing really quickly here, so this is going to be x and f of x. And this right here is going to be x plus h comma f of x plus h. So this is x right here. And then this right here is going to be x plus h. So this distance right here is technically h. And if we wanted to find the slope between these 2 points, technically it would be the slope of this blue line that I just wrote. So here on this one, if I wanted to use the formula for slope, it would be f of x plus h, which is your y2, minus your y1, which would be f of x, over x sub 2, which is x plus h, minus your first x, which is x sub 1, which would be x. And if we would simplify it, we would get f of x plus h minus f of x all over h is technically our definition of slope with this new notation that we learned in our previous class. So here, average rate of change, before we fill in these blanks at the top in this table, the average rate of change, also known as the slope quotient, is technically this f of x plus h minus f of x over h. This particular line that's in blue has a specific name. It's called a secant line. So the secant line is this blue line. It's a line that goes through 2 points on a function. So I'm going to put it here. This is the secant line. So even though these two scenarios, this one and this one, are definitely worded very different, their definition, or the equation, is the same. So what's new in this class are these: instantaneous rate of change and slope of a tangent line. So here on this one, let me explain what the slope of a tangent line. So a tangent line is technically a line that goes through one point on the graph. So this point right here, I'm going to try to put it in the same position, and this line now only goes once through that graph. So this is the tangent line. So really what happened is that this point, I'm going to highlight it in green, this point right here was h distance away, or spaces away on the x anyway, with respect to this point. Well, now on the tangent line, this point right here has now moved to be superimposed right on top of the red dot, the red point. So what happened? Well, the h value was here was h, but now the h is gone. So in math, for the distance between the 2 points is gone, means that h is 0. So here I'm going to write down h is 0. So the definition of the derivative, it's still technically the slope. It's still the slope. So the derivative is going to be the limit as h approaches to 0 of f of x plus h minus f of x over h. So this formula right here is used for these two. It could be the instantaneous rate of change. So it's going to be the limit as h goes to 0 of f of x plus h minus f of x over h, or the slope of a tangent line. So this, the slope of the tangent line is going to be, I cannot write today. The slope of the tangent line is going to be the same formula. Okay. So we're going to find the derivative. There's a 4-step process, which is technically just doing order of operations. So we have the formula. I'm going to write it right here. So it's going to be the limit as h approaches to 0. I'm going to write it more properly. Of f of x plus h minus f of x over h. So step 1 is to find f of x plus h. So I have f of x is equal to x squared plus 4x plus 7. And so f of x plus h is going to be, wherever I see an x, I'm going to put x plus h. Ah, shucks. So x plus h quantity squared plus 4x plus h plus 7. So it'd be nice for us to know that this first parentheses expands to x squared plus 2hx plus h squared. And if I distribute this, it'll be plus 4x plus 4h and then plus 7. Then step 2 says find f of x plus h minus f of x. So in essence, what's happening is I'm going to go ahead and substitute stuff in here. So I have the limit as h goes to 0. And this minus sign, I'm going to put it right here. And so f of x plus h, f of x plus h is all of this. So I need to write it down. So it's going to be, I'll write it in the same color, x squared plus 2hx plus h squared plus 4x, darn, plus 4h plus 7. Then I'll put the minus back in there, minus. Now I need to subtract f of x. So f of x is the original equation. In order to make sure that I subtract all of it, I need to put it in parentheses. So minus x squared plus 4x plus 7. So I'm going to highlight it in a different color. This right here is your original function. The next step says find f of x plus h minus f of x over h. So technically here I just have over h, and I need to distribute this right here. So when I multiply by a minus sign, everything inside changes to its opposite. So it's going to be the limit as h approaches to 0 x squared plus 2hx plus h squared plus 4x plus 4h plus 7, and it's going to be minus x squared minus 4x minus 7 all over h. And we need to collect like terms. So this x squared and this x squared simplify to 0. This plus 4x and the minus 4x simplify to 0. And the plus 7 and the minus 7 simplify to 0. So right now I'm left with the limit as h approaches to 0 of 2hx plus h squared plus 4h all over h. If you notice, the numerator has, they all have an h in common, so I'm going to factor it out. So it's going to be the limit, as h approaches 0. I'm going to factor out an h. So h times what gives me 2hx? It'll be 2x. H times what gives me plus h squared plus an h. And h times what will give me plus 4h? It'll be plus 4. And I have that h in the denominator. So this h and this parentheses are multiplying. And so I can very much say those two h's simplify to 1. And I'm left with the limit as h approaches to 0 of 2x plus h plus 4. And if h is headed towards 0, then it's literally, I'm going to write it saying it's headed towards 0. And so my answer is going to be 2x plus 4. That's my answer for the derivative. So I should say the derivative of f of x is equal to that. And that you need to realize is the equation for the slope of the tangent line of that graph. And it's also to find the instantaneous rate of change.